The next question is, on adding 0.1 molar solution of each of these ions to sodium sulfate solution of constant concentration, first precipitated is. So which one of the following cations, that is Ag plus, Ba2 plus or Ca2 plus, from the solution, which one of these three will be precipitated when sodium sulfate concentration is added? Indirectly, if I have, this is 0.1 molar solution of Ag plus ions and this is 0.1 molar solution of, so thus concentration is same, containing barium ions, and this the third one, this also contains 0.1 molar concentration but of Ca2 plus ions. To this, if we add sodium sulfate of same concentration, which of the cations? Is it Ag plus? Is it Ba2 plus? Is it Ca2 plus? Which one will be precipitated is the question. So for the precipitation to occur, we know that ionic product should exceed the solubility product constant, for which purpose solubility product constant of barium sulfate, solubility product constant of calcium sulfate, solubility product of silver sulfate, all the three are given. So we need to find out what concentration of sulfate ion is required so that the IP exceeds the KSP and the precipitation occurs. In whichever is the case, the concentration of sulfide ion required is less, the precipitation of that salt occurs, one which we need to work out. So let us calculate the amount of concentration of sulfide ion needed in each case. For the silver ion to be precipitated, we are supposed to get Ag2SO4, A2B type of salt. For this, the KSP expression can be written as Ag plus concentration whole to the power of 2 sulfate SO4 2 minus. And KSP of silver sulfate is given. How much is that? 10 to the power of minus 5. And what we need to find out, Ag plus concentration is already given 0.1 molar to the power of 2, in other words. Now sulfate ion concentration I have to work out so that Ag2SO4 can be precipitated. So for which purpose SO4 2 minus concentration needed is equal to 10 to the power of minus 5 by, this is 0.1, 10 to the power of minus 1 to the power of 2, 10 to the power of minus 2. In other words, it is 10 to the power of minus 3. So 1. Then for barium sulfate, BaSO4, it is simply AB type of salt. Therefore, Ba2 plus SO4 2 minus, KSP of barium sulfate is given how much? 10 to the power of minus 11. So 10 to the power of minus 11 is equal to Ba2 plus concentration, that is how much? 0.1 given into sulfate. So what will be the sulfate concentration needed, which we can calculate as 10 to the power of minus 11 by 10 to the power of minus 1. So it becomes 10 to the power of minus 10 molar. So this is second. For barium sulfate to be precipitated, we need sulfate concentration little more than this. Whereas this one, silver sulfate to be precipitated, is very high required. So sulfate concentration required here is much less than in this case. Similarly, we need to work out for calcium sulfate. For calcium sulfate is also similar to barium sulfate, AB type of salt. Similar method of calculation. So straight away let us work out sulfate concentration is equal to concentration of Ca2 plus with which KSP is to be divided. KSP is given as 10 to the power of minus 6 and the concentration is 10 to the power of minus 1 even for calcium ion. So it comes out to be 10 to the power of minus 5 molar. This is 3. So in which of these three cases the concentration of sulfide required is least so that the appropriate cation can be precipitated. This is 10 to the power of minus 5. This is 10 to the power of minus 3. Both of which are more than this. So for barium sulfate to be precipitated, the concentration of sulfide ion required is little more than 10 to the power of minus 10, which is least when compared to for other two. Therefore, the barium sulfate will be precipitated. Let us see the options. CaSO4, Ag2SO4, BaSO4. So therefore, the answer is C.